Hello again, everybody. Welcome back. I hope you enjoyed your coffee. And well, I will very briefly introduce you again, Wolfgang Kampichler, who is the co-chair of the Technical and Operations Committee at EENA and super expert on next generation 112. The floor is yours, Wolfgang.
Yeah, thanks, Christina. Just waiting to share my screen. And I suppose that after the break, everyone is refreshed and ready for the technical standards part. So second part of the presentation today. And let me share the screen. So I assume you can see my presentation. Yep.
Yes.
Thanks. Well, standards, why do we need standards? I think standards are key for innovation and compatibility. And I guess everyone knows success stories that have its origin in the mobile communications or in the internet. Yeah, so I guess success in emergency calling means that you get connected to the right PSAP or the correct PSAP or service. And today, it's not only get connected, it's also provide new data or media that can be exchanged to help dispatching the proper resources. The most important information that we share with the PSAP or can we share with the PSAP with this new technology is, for instance, the location. When looking at the standards, we need to consider the originating network and for sure the PSAPs. So on the left side on the presentation, you see different types of originating networks. So we have soon the next generation eCall, we have voice over LTE being around, we have voice over IP solutions. As Luca mentioned in his presentation, there is Microsoft Teams, for instance, that might be used at home, and you need to dial emergency services, and then it depends where the breakout is set and to which PSAP you get connected. And still, we do have legacy technology like PSTN, and all this needs to be considered when it comes to standardization. And on the other hand, in Europe, you know, we have different types of PSAP models. So there might be interconnected PSAPs to serve different regions, or there might be stage 1 or stage 2 PSAPs. And there might be situations where you have to connect cross-border just for cooperation purposes, or like in Austria, it's not the national border, it's more the border of the federal states, because the federal states are responsible for emergency services. And common to all that is that you need something in between that performs this mapping task that Luca mentioned, and that also performs the routing. So we need some services to support location-based routing and send emergency calls to the correct PSAP. And for that, we have standards that define the interfaces. So which means interfacing from the originating network to some core services, let's call them NG112 core services, and on the other side also interface to different types of PSAPs. And for that, we have standards that define a certain feature set. So for instance, if it comes to mapping, the most common feature is find service by location, which means you just send the request, you provide the need, which is called a service URN, you provide the location, and what you get back is the technical address of the correct PSAP or the PSAP serving for a specific region. And this is not only to get access to the specific PSAP, those interfaces can also be used, or certain interfaces can also be used in order to get cross-border interoperability. So for instance, if a call needs to be forwarded or retargeted to another PSAP because it was misrouted, or someone is calling on behalf, then you can also utilize the same interfaces. So basically, in the standards document, you find those functional elements that are responsible for the mapping and routing purposes, and also an idea how to get the location information from the different sources to the PSAP. But that's just one thing. The other thing that is considered in the standardization is the media and data interfaces. So here it comes more to the originating devices and to the end systems in the PSAPs. So the mapping and routing process in between is always the same, no matter what kind of media is going to be exchanged. But you need to have those specific media and data capabilities in the end devices. And just remember Lucas' words mentioning that if you have a mobile network operator and you have an end device being capable of starting a voice over LTE emergency call, it might be very helpful, or it is very helpful if that end device also provides location information with the call setup that can be used for routing purposes, for instance. And then there might be additional services provide more accurate location when it comes to dispatching. So that means the call already arrived at the correct PSAP. In terms of media support, the focus is also on the accessibility. So real-time text and video is specified. So the minimum requirements that are needed for a video call, to use sign language, for instance, and also the technical specifications of what does it mean to do a real-time text. So you find this in the in the specifications, and this actually helps, as mentioned before, that you can access a PSAP, you can provide additional data, being it real-time text, being it a chat or image transfer, whatever, and you may also share this information with other PSAPs. So standards are actually not only nice documents to read, but should also be implemented and tested. And there are two main initiatives, one in the US, it's the EENA initiative. I stands for Industry Collaboration Events, and in Europe we have the ETSI plug tests, so also supported from the EENA. And recently we had one very important and very successful event because we joined forces. So we had a joint event between US and Europe where we tested the secure peering, for instance, between different ESINets. So we had an ESINet deployment in the US, an ESINet deployment in Europe, and we had different models for the peering. And in order to do so, we introduced additional elements like a location information service that connected to a mobile network operator. Actually, this event was the first one where we had a mobile network operator joining and originating voice over LTE calls to emergency services. And in our different test scenarios, we get the chance to route calls to Europe, to answer them at the European PSAP, or to reroute via the European ESINet deployments, and do a lot of very important or very interesting scenarios to also make sure that we have this interoperability not only in Europe based on the HCTS 103.479, but also with deployments or with technology provided or following the US standard that is EENA STA 010.2, for instance. Besides the interoperability testing, we also have equally important the conformance testing. So there are specific documents around that describe what needs to be done in order to prove that certain devices based on the standard specification. So that means that there is not testing between different vendors' equipment, but there is testing between one vendor's equipment and a specific test tool. And then the test tool just validates if the implementation is conformant to the test to the standards document, or the specifications that are in the standard. So that is still working. That's still something that need to be extended. So we do have a basic setup for this conformance testing, but there is still work ongoing to enhance that specification and to cover all the functional elements that are part of the standards document. Some important thing I would like to mention here is that since we have this kind of cross-border situation, or this peering of different ESINets, there are also new elements that you won't find in the national deployments. They're called forest guide. So they're just helping to find the right or the proper elements in the remote network. So if a core needs to be transferred, you still route via the local ESINet, but if there is no specific mapping for a location that comes in to the ESINet, for instance, then the elements may want to send a request to the forest guide, and the forest guide would then know, okay, this is a different country, and I know where to find the mapping service. So that would allow that calls can be retargeted from one ESINet to the other ESINet, just following the same interfaces and the same standard specifications. And as well, as already mentioned, it's not only the signaling that has been tested, we also tested different types of media. So having multimedia calls coming from this VoLTE terminal, or real-time text, and this was answered by PSAPs with the same capabilities. So that's also important message that not only the originating side needs to have or support these capabilities, these new types of media, but also the terminating side. So the receiving PSAP needs to have certain capabilities to answer that multimedia call. But since we're talking about standards, the good thing is that standards have the capability to negotiate media. So it doesn't mean that if one PSAP doesn't support video, that there is no call at all. It's just limited to audio, for instance. So that's it for the testing. And next, let's talk a little bit about the NG112 project that we started in 2019. Just referring to Luca's nice calendar in the presentation. So we started this in 2019 and concluded this project or finished the project in 2020. And there were 3 different projects like shown here. So we had one which is called CEST, which had the focus on cross-border, cross-vendor use cases, and also the introduction of a forest guide to perform these international roaming scenarios. We had one project in Croatia with the focus on WebRTC and multimedia use cases, and there was another project in Turkey which had the focus on applications and IoT, like introducing intelligent home speaker. So each of the project had a different focus, and please note that this is just an overview that I'm giving here, and you may visit the EENA website to see detailed project reports of each of the projects. And I think there were also webinars. You can still have a look at those recordings to get more details. But just for the overview, CEST, this was an NG112 ESINet deployed in Austria, Denmark, and Italy, with the focus on the cross-border testing and also on the secure peering of different ESINets. So, for instance, getting a call coming in by a mobile network operator in Austria, for instance, getting connected to the PSAP. If it's 112 in Austria, get connected to the police. And we did the same scenario, just moving across the border to Italy, but still being connected to the mobile network operator in Austria, which means we still got the call connected to the Austrian PSAP from Italy, and doing the same with the NG112 deployment. We had a specific application providing the correct location. We used the forest guide, the mapping and routing instances in the Austrian ESINet to get connected to an Italian PSAP being responsible for that region. So in addition to this kind of cross-border scenario, we also had different vendor implementations to participate, and we connected the different ESINets or components of different vendors to each other, just to figure out is this also something that works in real life. Next project was in Croatia, so that was quite interesting in terms of introducing new types of technology like WebRTC. So just remember Luca's presentation mentioning that there might be in the future codes just originating from the browser. And what the Croatian team did is having or introducing a WebRTC-based application, so that's the technical term for these browser applications that support real-time communications, and connect such an application to next generation 112 core services network nationally deployed. So there was just national routing and mapping, but they also include location information service. So the idea is here that you provide some identity and there's some service knowing about the location of the origin device or application, and that's being used for routing purposes, and if accurate enough, also for dispatching purposes. The other quite interesting project we had in Turkey. So here it was the integration of let's call it a third-party application from the Turkish Ministry of Health, being the originating part, having an NG112 core deployed nationally, and combining this with PSAP solutions. And quite interesting here was the integration with IoT devices. So there was a specific IoT use case with an intelligent home speaker that was used to recognize some keywords like fire or help, and then automatically dial and connect to emergency services. So even if this is kind of a robot or automated thing, you can connect it to these core services and get connected to the PSAP. So depending on the capabilities of each end system. The overall project conclusion of this NG112 implementation project, I think, is that common to all of the different things and that has been tested was the next generation core service deployment. So this entities I mentioned at the beginning that are being standardized and they provide standardized interfaces are the key enablers for different applications and different media types. So you see WebRTC, you see IoT, in the future you may see the next generation eCall, voice over LTE, everything's coming into that infrastructure and being forwarded to the right PSAP. In some of the scenarios, we also had this cross-border, cross-vendor testing in place. Finally, one example of an operational NG112 deployment in Europe. It's called TEC 112, and this is in Austria. So it's based on the NG112 standards, TS 103479 and TS 103698. So you can find this on the internet. It supports text chat, so it's kind of WhatsApp-like service. So if the user just one of the buttons at the application, he or she gets connected to the right PSAP. So in Austria, we have different services. We need to connect to different federal states PSAPs. And we also have included a kind of info bot that this is just a bot service that answers or provides very generic information regarding COVID. And it started actually as private initiative, received some national funding, but it is to be operated permanently by the Austrian Ministry of Interior. And actually currently there is a specific amendment to the Telecommunications Act in Austria that is currently under review. So I hope that that's soon being reviewed and we can just move on with a permanent deployment. The most interesting part of the deployment here is the NG core services that already run in Austria. So we have this mapping and this routing capabilities deployed, and the specific deaf emergency call app called NG112 is just the, let's say, the user of this core services. So the application connects to that core services, supports the standard interfaces as being specified by ETSI, and therefore emergency calls that are set up can be connected to the correct PSAP. And as mentioned before, in Austria, we have to forward calls or chats to federal state PSAP and to different services. So we have services for the ambulance, for the fire brigades, and for the police. So this needs to be separated. And what the project also provides, beside the NG112 applications, is also a certain backend that can be used for migration purposes. So that allows, in a simple way, PSAPs to connect to this NG infrastructure. And since we have these core services deployed in Austria, we do see this as enabler for further services like other PSAPs connecting to that, or perhaps other applications joining in, or even mobile network operators may connect. And we'll see how this evolves. But to summarize, it's a real nice example to start small, to get an NG112 core services up and running and to see how it works, and then just scale to further services and to further applications or ideas that can be integrated with such core services. Yeah, let's conclude with some screenshots and statistics. So this NG112 service is live since the 112 day in 2019. There are some statistics, so they're 1 week old, but you may have a look at the web page to see the most recent ones. And the pictures just show the Emergency Services Law Austria and the Ministry of Interior. This is a PSAP control room where the emergency chats, since the NG112 is a chat service, are received, and the, if necessary, resources are dispatched. That's it. So many thanks for your attention, and I'm happy to answer questions.
Thank you, Wolfgang. So we have some questions. We are running a little bit out of time, so let's see how many we can. I think we have time for 2. So we have first from Calgary, 911. In Canada, we are pushing for creating a lab, NG-CEST for testing software upgrades and feature testing. Does EENA has any similar initiative to verify any upgrade does not result in call failures?
If it's a question for EENA, Christina, perhaps it's for you.
Here, please go ahead, Wolfgang.
I mean, what we try to do is with the plug test initiative is test before, and integrate as much as possible originating networks to see if there are some, let's say, problems with the integration to avoid problems later on. But I think so far there's no initiative to do this in a deployed environment, if I got the question right.
Okay, we are still not thinking about this right now. So as Wolfgang said, the tests were before this, but we can, of course, think about it in the future. Let's jump to the second one. It's about standards. How important is M493 to next generation 112? Do we need to implement all aspects to achieve next generation 112?
I think that's a good question, and for sure, M493 resulted in a ES, and the ES describes very well how to interface with an ESINet, for instance. But you may not have to implement everything. So if you just look at the specification of certain interfaces and also at the references provided in TS 103479, you will find or you get an idea of what interfaces or reference points are the most important ones to get connected to an ESINet. So, but perhaps it's just a subset that is necessary to be implemented, but it really depends, I think, also on national regulations. But this is covered, and there are the right references in the ETSI technical specification dealing with the NG core services.
Okay, and we have also another one from Calgary 911. Does implementations in Europe use EIDD, EIDO for transferring data between PSAPs and to CAD systems?
Currently not. So actually TS 103479 just covers the emergency calling part of the NG idea. But I think as soon as there are some requirements coming from European PSAPs, we will also cover that. But you have to consider that in Europe, the PSAP models are a little bit different compared to the US. So what we do see in Europe is that there's more or less a consolidation moving from, let's say, this county level PSAPs to federal state PSAPs. So there might not be that much of exchange in data, but if necessary, for sure, I would also consider the standard interfaces like the EIDD.
And the last one, I think we have in Turkey project, did the IoT call directly the PSAP? Did you get false alarms?
Oh, that's one detail I can't answer, but you may have a look at the final report. I think that if you integrate with IoT, that's just my personal point of view, then you may at least have to provide this information to the PSAP that this is an automated call, and that there need to be some means to, let's say, connect back to the calling party and just ask if there are some issues, like for instance with the e-call that you can just open a conversation. If it was automatically started. But to your question, I would recommend to read the report or just directly connect or get in touch with the team.
I don't think they got too many false calls from what I remember, but of course we can put you in contact with a team from Turkey. Okay, so we will come back to the questions after the last presentation of today. Thank you very much, Wolfgang. Please stay with us for the final Q&A session. And we will give the floor now to the next speaker, Michael Pröstler.
Yeah. Hello, everybody. Hope you can see me and hear me.
Yes, Michael, we can see you and hear you and even see your presentation. So I leave now to you the floor.
Yeah, thanks, Christina. Yeah, hi, everybody. My name is Michael Pröstler, and I would also like to welcome you today to this webinar. And I'm going to talk about some implementation steps and guidelines you need to be aware of when realizing NG112 and basically how to get from theory to reality. So we've already heard why we need NG112 and what it is and what are the multiple use cases, scenarios, and capabilities. So I'm going to focus more on the non-technical aspects and how to get from theory to reality. And this includes which processes you need to think of and which need to be established, what important milestones there are and need to be achieved, and of course, which stakeholders you should get on board for this venture. And these guidelines follow a kind of inside-out approach, meaning that we're trying to get additional benefits along the way without even having yet a full end-to-end rollout of the NG112 architecture. So in order to getting started, as for any project or any idea, you need to bring the people together who are responsible for realizing the project. And in terms of NG112, there are multiple stakeholders involved. And ideally, you should get representatives of each of those stakeholder groups into your responsibility group. And those includes representatives from national authorities, PSAP operators, representatives from the regulators, but also, of course, from the mobile operators. Coming to an important aspect of the realization, the budgeting, which is, of course, an important aspect. And you should consider some areas like, of course, the procurement and the operations of the NG112 core services, and, of course, over the overall ESI net. In addition, I mean, we had 50% of the PSAPs said that they are already on SIP trunks, but you might consider some additional funding for PSAPs upgrading their technology, and also some funding maybe for telco providers to connect to the ESI net. And of course, overall project and the program needs some management, and you also should consider that in your budgets. So we've broken it down to 7 steps, 7 milestones, with the final goal to have a European-wide or probably even worldwide interconnected and interoperable emergency service. And what is important is that although it is European-wide or worldwide, that each country keeps its local autonomy, which is quite an important aspect, that each country is still in complete control of its own ESI net. However, through using the same interfaces and the same architecture of NG112, we have interoperability. So that means that we can forward calls between the countries, and so for the end user, for the people in an emergency situation, it seems like there's only one system. So how do we get there? So the first step would be to come up with your emergency service strategy plan. So you need to think of a lot of things when starting realizing NG112. And one thing is, of course, which emergency services do you want to provide? There are some obvious ones like fire, ambulance, or police. And depending on your country, others like water rescue or mountain rescue. Once you know those services, you should plan on how do you want to provide those services. As Wolfgang said earlier, there are many different PSAPs models, and so you need to think about what is your emergency service model? How do you want to provide those services to the user? Do you have filtering PSAPs, staged PSAPs? What are their geographic jurisdictions, and how do they integrate with each other? So for example, you can have multiple PSAPs peering with each other, maybe sharing some geographical jurisdictions, or you have PSAPs which are the designated fallback for other PSAPs when they are under maintenance or under heavy load, for example. So all of those scenarios should really go into your emergency service strategy plan. So the next step is, once you have your plan, you can start realizing the 112 architecture. But before deploying the actual core components, you need to create the infrastructure where they are hosted, basically. And since everything is IP-based in NG112, this is also known as the ESI net, the Emergency Services IP network. But it's not only about the network infrastructure as such, but also about authentication and authorization. So since communication between the different services within NG112 use mutual TLS authentication, you would need a national organization which issues those certificates. So this national organization then can decide or grant access to the ESI net, can specify under which circumstances, under which technical requirements vendors or services get access to the ESI net. And yeah, testing is is definitely an important part of that as well, and this would also play into that direction. So you would need to pass or demonstrate some capabilities and conformance to the standards in order to get your certificate and access to the ESINet. So once you have the network in place, you can start with the procurement and the deployment of the NG112 core components. And those components really, they provide the functionality within the NG112 architecture. So you have the emergency service routing proxy, the PSAP, which is basically the element which is able to route conversations based on various rules like location, daytime, nighttime shifts, the PSAP capacities and capabilities, or even their state if they are currently under load or under maintenance, for example. Then we have the emergency call routing function, the ECRF, which provides information which PSAP is responsible for a certain service at a given location. Then the location information service, the LIS, which provides location information for entities, and it can be connected to different sources. So for example, it could be connected to telco providers to perform a lookup and localization via cell tower. It could connect to telephone books for landlines and find the address of a certain phone number. But it could also be an endpoint for AML, for advanced mobile location. And in that way, it can provide one interface, one standardized interface to all the components and services within the ESINet, independently of where the original location was provided from. And this, of course, because there was earlier a question whether there are NG112 supports updates of location and whether all the routing information is available on the NG112 interface. And this is clearly a yes. So you can send updates, probably handled by the LIS, and also all the information is passed through transparently to the PSAP. All of those components, they can be integrated using the standardized interfaces. As already said, it's specified in ETSI's technical specification 103479. And this enables you also a best of breed approach. So you can pick different components from different vendors and connect them via those standardized interfaces to avoid a vendor login and get basically the best components available on the market. So once we have all the core services in place, the next step is to integrate the PSAPs or to enable the PSAPs. And this includes potentially upgrading the current solution to handle IP-based emergency calls. And of course, in addition, if you already can handle IP-based or voice over IP calls, you need also to be capable of evaluating and processing the additional call data, like for example, the location information, which comes with the initiation of the emergency conversation. But PSAPs not only need to think about the technical upgrade, but since NG112 enables different kinds of media like video or texting, PSAPs also need to think about their internal processes and how they will handle such emergency conversations. As an example, a text-only emergency conversation might be needed to be handled differently or even by separate operators than the standard voice-based emergency call. And then once the PSAPs are ready, you can finally establish the connectivity to the ESINet and perform some configurations on the NG112 core components to actually route calls to the PSAP. So one important step or point here is that as soon as the PSAPs are ready, you can already benefit from the ESINet and the IP-based emergency services without even having yet a full end-to-end LTE-based emergency conversation. So for one example, you can integrate IoT providers, as we already heard from the projects. You can integrate sensors, you can integrate automatic alarms, for example. You have video surveillance capabilities, for example, where you automatically trigger voice over IP call into the system, and that everything is transparent for the PSAP when they follow the standardized interfaces. Another important aspect is that you can integrate over-the-top applications. So you can have multiple applications if they're following the same standards and they provide, for example, text messaging towards PSAPs. It's completely transparent again. And same thing goes for voice over IP providers. You can integrate voice over IP providers like Microsoft Teams, Skype, or any other basically zip trunk providers. So as you see at this stage, we already can benefit from the NG112 architecture. So the next step would be to push it more out to the mobile phones. So here in step 5, we need to connect the mobile network to the ESINet. So mobile operators simply need to forward emergency calls to the ESINet and enrich the calls with additional data, like for example, the cell tower location or the subscriber information. For example, for landline calls, they could include or enrich the call with the address before forwarding it to the ESINet. And this way, basically, they would transform a normal GSM call into an NG112 emergency conversation. At the same time, the mobile operators should prepare for voice over LT and video over LT for emergency call. So once the capabilities, the LTE-based emergency capabilities are available on the network, the operating system should use them when there is an emergency conversation. And similar to what advanced mobile location currently does is once the mobile operating system detects that an emergency conversation is triggered, it should receive and include the handset's geolocation in the setup of the conversation. So this will finally result in an end-to-end LTE-based emergency conversation, enabling all the capabilities we've heard, like voice, video, and text. And another important aspect is when thinking about mobile applications. So mobile applications still provide additional value. So for example, they can integrate additional sensors, IoT devices, or apply additional logic when an emergency conversation should be initiated. Ideally, the mobile operating systems provide an API for such applications, similar to what they provide now for normal phone calls. So applications should be able to trigger an emergency conversation and add additional data. So one example would be, imagine a motorcycle app which detects a fall or an accident by having some sensors on the motorcycle. And it would then integrate with the API, initiates the emergency conversation, and attaches additional information like vehicle speed, number of persons, etc. All this information would then be transparently transmitted through the ESINet and the NG112 components to the corresponding PSAPs. And operators can view that information and in that way enrich situational awareness. At this stage, we have a nationwide rollout of the NG112 architecture. So in order to establish an interoperable European-wide, worldwide ESINet, we need one last step. And this would be to being able to forward emergency conversations from one ESINet to another. And again, similar to what we had in milestone 2 on a national level, we need some authorization and authentication mechanism. So having a common European authentication and authorization mechanism then allows us to transparently forward calls between ESINets. And again, by using, for example, a forest guide, which is a kind of a lookup for the different ESINets, we can keep each country's local autonomy. So each country is still completely in control over their own ESINet. To sum it all up, what I would like you to take away from this presentation is that you can and should start with your NG112 implementation now. You can do that via some pilot projects or tryouts in limited areas, for example, to gain experience. You can get benefits along the way, even without having a full end-to-end LTE deployment yet. So it really does not depend on your country's rollout of voice over LTE and video over LTE. And last, but definitely not least, that the NG112 architecture provides really a blueprint for modern, interoperable, and extensible emergency services. And in that way, it is really the foundation for future innovation in public safety and how you will interact with the public in emergency situations. And with that being said, I would like to give the floor back to Christina for some questions and answers.
Thank you, Michael. I think we have now the way to more ideas on the way to implement next generation 112. And I will invite all of the speakers of today to, so Luca and Wolfgang and Michael to join now the final Q&A session with some questions that we didn't have time to answer before, or new ones that may arise. So we had one just at the end of Wolfgang's presentation about the compatibility synergies between next generation 112 and PMEA. I don't know if one of you would like to answer this one. I don't see Luca. Luca, are you there?
Sorry, I'm here. Yeah, sorry, I was in mute.
Okay, so we see you.
No, sorry. Okay, yeah, PMEA and NG112. I've been inside the original PMEA work group. I would say that the two networks, first of all, there was a plug test where we tested interoperability and compatibility with the two. But we have to consider this very important element. So PMEA, the name says Pan-European Mobile Emergency Application, and I add network. PMEA is dedicated to smartphone applications. So in principle, there is a very specific topic and a very specific environment where it moves around. If you look at NG112, we've been talking about IoT, laptops, and other devices which may access to the network in a let's say more open way. No? So I would say that the two networks can work jointly, can talk to each other, they can even coexist in parallel with touching points, with interoperability. The LIS, for example, the LIS component among the core components of the ESNet could be an appropriate touch point between the two. So I don't see any particular competition in this space. Each of them could be focusing on a scope, very precise for PMEA, more wide for NG112.
Okay, we had also another question from Christian in Norway about SIP and location. Does the SIP protocol support sending continuous updating of position from the cell phone? I see.
Yeah, I think, yeah, yeah. I tried already answered during my presentation. Yes, also the list supports, let's say, also notification mechanisms. So as soon as it receives, for example, a new location, it can push it towards the PSAPs, but also within, let's say, the communication channel between the caller and the PSAP, you can send updates to the location, and in that way supporting the, I think it was about the car hijacking scenario.
Yes, indeed. Anything to add? We can jump to the next one. Okay, we had another question from Norway. Many PSAP solutions are now cloud-based. This means that all emergency calls to an agency will be routed to one or two central points, and this system will have to route these calls itself. Is our location and routing information available for the agencies on the NG112 PSAP interface?
Yeah, I mean, again, all the information which is available within the ESNet and for routing purposes is passed through to the PSAP. So elements within the the architecture can add additional information, but the existing one will be kept and will be available wherever you received the voice over IP call.
I think in addition to what Michael mentioned is that for sure there are different PSAP models and not only the PSAP model but also the deployment models may differ, and it may come to a situation where you need, let's say, more from the NG infrastructure, more features, more services, or less. So if you say, okay, everything is centralized at one point, it looks like stage 1, stage 2 PSAP scenario, you may not have to do all this routing magic. But for sure, you may want to get the location information. You may want to get different types of media. So there is also an aspect of NG, even in such a situation. And this, as Michael mentioned, all the information can be provided to the PSAP. So that's usually the case when looking into the specifications.
Yeah. Just think about the case of the TPS call we mentioned before. Now, when you have this TPS call, you need to get a call to a destination that eventually look for the corresponding data, make a match. May be quite complicated. It is quite complicated today. Imagine if tomorrow your PSAP receives a SIP-based call, and inside the same call you have signaling, so your phone rings, and together with it, the location is delivered even before you pick it up. And also the equal data is delivered right on your screen. So when you pick it up, you already have the data automatically on your screen.
Okay, thank you. And I think it's important also what Wolfgang has said about the different models. So yeah, each country has its own organization, and of course the next generation 112 can also adapt to this organization. So it's not a central point and then everything goes with this model. We have another question. When could we expect next generation 112 to cover communications from the PSAP to the field agents?
Does that mean, not sure if I understand the question correctly, but if that means the communication to the officers on the street, then it's more or less covered by MCPTT rather than by NG112. But I'm not sure if I understood the question correctly.
Yes, I think this was the point to make the difference. I don't know if Wolfgang, yes, please.
I think it depends on how soon you get this, let's say, modern dispatching technology deployed in your country. So as Michael said, this mission critical application services where everything is actually based on let's say simple terms, voice over LTE. Then you have also the capabilities to share other types of media, because you have, let's say, a broadband pipe to the officer on the street. So then I'm pretty sure that there will be products around that support this kind of patching between the incoming data and the outgoing data. But as I said, it depends on the infrastructure that needs to, let's say, support this kind of broadband features.
Okay, and we have another question from Egypt. In case of calling from OTT, is it going to be routed to the same PSAP? If yes, what in the case of having false calls?
If I can say something, thank you for the question, because it's highlighting another very important aspect of NG112. So in case we're gonna have calls from OTT like WhatsApp or the others we mentioned before, where you will be able to simply dial 112 from those applications and do the same things you're doing with your friends, like sharing position, sharing a picture, making a video call, and so on. The selection of the most appropriate PSAP may be simply based on location, or even based on the application you're using. me, Wolfgang, and Michael, during the Celeste project we participated together, we even made an example where, using two different source applications, we could route the calls to an appropriate PSAP depending on the application used. So the ESINet was recognizing I was using application number 1 or application number 2. In the same way, an ESINet could recognize that you're using a normal, let's say, SIP call from your phone, or that you're using WhatsApp for calling. Regarding fake calls or people sharing inappropriate data, I'm afraid NG112 cannot help versus, you know, these kind of things, unless, of course, you create rules and mechanisms to prevent it. But these do not depend on NG112 per se. Like we said in the beginning, this is a technology enabler.
In addition to what Luca said, I would just refer to this Austrian example where we have this this over-the-top application tag 112, and it was very important to verify the users that are using the application. So there are mechanisms around, like for instance, if you just use WhatsApp, your device will be verified based on your number. And since numbers are registered in Austria, you can find out who is actually originating a call if it was a, let's say, a misuse or something like that. And there are means to protect your infrastructure for sure. So if you have an over-the-top provider, I'm pretty sure that this one is not coming out of the wild. The provider would have to peer with an ESINet, which means exchanging certificates, exchanging other technical information. So I think if you do have the right process enabled or in place, then you can make sure that or at least you can avoid most of those misuses, because you can trust one of the providers if the provider can, let's say, guarantee that all the users can be identified, for instance.
Okay, thank you. I think we have another question, and I think it will be the last one because we are already running out of time. Yura Bara from the European Commission: can a VoLTE or VoLTE communication using the 112 number be routed to the most appropriate PSAP without next generation 112?
Good.
It's a good question.
Well, but we can refer to our Celeste project. So we used, I think it was not a VoLTE core, but it was a 112 core. I think it still depends on the capabilities of a mobile network operator, how to route a specific call. So I'm pretty sure if you're calling, let's say, from Italy, but still being connected to a mobile network operator in Austria, and it's a voice over LTE call, you get connected to an Austrian PSAP. So this means it's not routed correctly. So from my point of view, I would say no. If there are no specific means within a mobile network operator's network, like the capabilities we introduced with NG112, then it would be misrouted. But Michael and Luca, perhaps you have.
Well, I agree.
Okay, if there's nothing more to add, I think we can close now the session for today. I will just quickly share with you what is going on tomorrow. Before this, I will really thank you, Wolfgang, Michael, and Luca for joining us today, for sharing your knowledge with all of us. I'm sure that if you have further questions, the three speakers will be happy to respond them by email. Also, you can, of course, contact me or other colleagues at EENA. And I thank you very much again. And we have now on the screen what's going on tomorrow. So tomorrow we will have examples of implementations, experiences of people who have already started implementing next generation 112 or next generation 911. So we will start at 2:30 p.m. Brussels time. From the practical side, you can use the same link as you used today for tomorrow, and also for Thursday, where we will have a presentation about the next steps on implementing next generation 112. So that's all from our side. Thank you very much again for attending this webinar, and see you tomorrow. Bye.
Thank you.
Thank you.
Bye.